Welcome to Brain Vision.
Okay, so I see that you need help with this question. It says medical researchers have devised a test that quantitatively measure a person's risk of heart disease. The test scores for general public are approximately normally distributed with a mean of 50. On the test, higher test scores indicate a higher risk of heart disease. An advocate of long distance running believes the marathon runners should have a lower risk of heart disease than the general public. A random sample of 20 marathon runners is selected, and each is tested for their risk of heart disease. The test scores have a mean of 43.7 and a standard deviation of 4.2. Construct a 90% confidence interval for the true mean score of all marathon runners. So for this, so it's an average of 43.7 and sample size is 20 and a standard deviation of 4.2, and it was a 90% confidence interval. And so that means that the t-score is going to be, if you look at a t-value chart, it's going to be 1.7291. So you're going to take your mean of 43.7 plus or minus 1.7291 times your standard deviation of 4.2 divided by the square root of 20. And so that's 43.7 plus or minus 1.6239. And so you're going to have a confidence interval of 42.0761 to 45.3239. And so then suppose a researcher is studying the effectiveness of the long distance running on heart disease, and they wanted to increase the confidence level of 95%. So what would happen? So what would happen is the spread would increase. And if you have a 95% confidence interval, the margin of error is going to get greater, which means the margin of error would be greater. So right now, the margin of error is for 90% is the 1.6239. For a 95% confidence interval, the margin of error is going to increase to 1.9657. And so then your confidence interval is going to be between 41.7343 to 45.6657. And so suppose the researcher was able to increase the sample size from 20 to 40. What effect would this have on a 90% confidence interval? So your margin of error would be the same. So you have 43.7 plus or minus, then you have 1.7291 times your 4.2 divided by your square root of 40. And so with the sample size increasing, then your margin of error decreases. So it would be 43.7 plus or minus 1.3432. So margin of error decreases. So I hope that this video helps. This is a middle school math teacher signing up.